Hi everyone, welcome to your maths lesson for today. So we're going to start with some fluency, and what we're going to do is we're going to try to bring together all that learning about multiplication and division that we've done in fluency over the last week. So I've got some STEM sentences for us here, and we're going to finish those STEM sentences. When 0 is a factor, so when we have a multiplication and 0 is a factor, so that's either 0 times by something or something times by 0, the product is always, what do you think should go there? That's right, well done. The product is always 0. That's because if I've got either 0 groups of a number or I've got a number of groups of 0, then I don't have anything. Super. The next one then. When you try to divide 0 by a number, so this is now when I've got 0 divided into groups of 1 or groups of 3. So when you try to divide 0 by any number, the answer is always 0. Fantastic. If I'm starting out with 0, I've got nothing. There's no way I can share that into groups of 2 or groups of 5 because I don't have anything. When you divide a number by itself, so this is if you're doing 2 divided by 2, 10 divided by 10, for example. So when you divide a number by itself, the answer is always, can you remember? 1. Excellent. The answer is always 1. Super. When you divide a number by 1, the answer is the same as so this time I might have 5 divided by 1 or 10 divided by 1. The answer is always the same as the whole. Excellent. So the answer is always the same as the number that you're starting with. So given these STEM sentences then, I'm going to reveal some questions for you to put those into practice. There you go. So we've got 0 as a factor, 0 divided by a number, numbers being divided by themselves, and then dividing by 1. Pause the video, go through as many as you can in, let's say, 5 minutes, and then by the time you play the video again, we'll go through the answers. Lovely. So hopefully you've had a go at that and you're now ready to go through some of those answers. So let's start with timesing by 0. So 0 times by 7, well, I know that when 0 is a factor, my product is always 0. Oh, now my product has moved to the front of my equal sign. So 0 times by 12 is the same as 0 again. Same again, but this time 0 has moved to the opposite side of that multiplication symbol. So 11 times 0, well, 0 is still a factor, so my product is 0. And 8 times 0, same again, 0 is a factor, so my product is 0. And this time I've got the first factor in my equation missing. Something times by 9 equals 0. Well, I know that when my product is 0, one of my factors must also be 0. It's that same sentence, but it's just in reverse. If I know my product is 0, then one of my factors must also be 0. Fantastic. So now let's have a look at what happens when we try to divide 0 by a number. Well, when we try to divide 0 by a number, the answer is always 0. So 0 divided by 1 would be 0. 0 divided by 5 would be 0. Now, this time my answer has moved to the front of my equation. It's still the same thing. 0 divided by 10 would be 0. Oh, this time it's not my answer that's missing, it's actually my whole that's missing. So something divided by 2 equals 0. Well, I know that if I'm going to get the answer 0, that's because I don't have anything to start with. So my whole must also be 0. Same for this one then, it's the whole that's missing. So my whole divided by 4 equals 0. Well, if I don't have anything, that's because I don't have anything to start with. So I'm starting with 0. Lovely. Let's have a look at what happens then when we're dividing a number by itself. So 3 divided by 3. Well, when you divide a number by itself, the answer is always 1. So 3 divided by 3 equals 1. 6 divided by 6 equals 1. Oh, this time it's my answer that's moved to the beginning. My equation is still the same, except my answer is now at the start. So 12 divided by 12 is equal to 1. This time it's not my answer that's missing. I know that my answer is 1. So something divided by 7 equals 1. Well, we can use that same STEM sentence, but just use it in reverse. So when you have an answer of 1, the whole must be the same as the number that you're dividing by. So I know that it has to be a number divided by itself. So this must also be 7. And this one is missing. So 9 divided by something equals 1. Well, it's that same thing again. I know my answer is 1, and this happens when I divide a number by itself. So if I'm starting with 9, I must also be dividing by 9. Excellent, well done. And then over here, we're dividing by 1. So when you divide a number by 1, the answer is the same as the whole. So 8 divided by 1 equals 8. Fantastic. And 13 divided by 1 equals, what's my whole? It's the same, it's 13. Well done. So again, my equation has flipped around so that my answer is now at the beginning. So 10 divided by 1, it's the same as my whole. This is my whole. It's 10. Oh, now this time my whole is missing. So something divided by 1 equals 5. Well, once again, we can use that knowledge in that STEM sentence, but just use it in a different order. So when I try to divide by 1, the answer is the same as my whole. So if I know what my answer is, I also know that my whole is 5. And same again here, something divided by 1 equals 7. Well, when I divide by 1, the answer is the same as my whole. So if I know that my answer is 7, I know that my whole is also 7. Fantastic, well done. I hope that you were able to get all of those right and really use all those things that we've been learning in the last week. Super. So today we are going to be looking at doubling. So what we're going to do is we're going to warm up by counting in our 2s, and I'm going to point with the mouse and we're going to count along in our 2s. So let's get ready. 1, 2, 3, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Super. Let's count backwards from 24. 1, 2, 3, 24, 22, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0. Excellent. So my question for you is, what do we already know about our 2s? When we count in our 2s, or we might call them our 2 times tables now, what do we know about them? Just pause the video and tell somebody or talk to yourself. What do we know about our 2s? Think back to that patterns lesson where we were looking for patterns with our times tables. Lovely. So hopefully you've had to think about what you already know about our 2s. And I'm hoping that some of you have said that they all end in either a 2, a 4, a 6, an 8, or a 0. And that means that they are all even. So all of our 2 times tables, when we count in our 2s, they're always even. It would be impossible for us to have an odd number in our 2 times tables. So moving on then, I have got some children sat on a seesaw. I would like you to have a think about what addition equations are being represented by the seesaws. So this is my middle bit. On this side, I've got 1 child, and on this side, I've got 1 child. So I would say that these are my 2 parts. So I've got 1, add 1, and my whole is the number of children I've got all together, which is 2. So I would say 1 plus 1 equals 2. Nice and easy. Why don't you pause the video and write down the equations that are being shown by the second and the third seesaws. Lovely. Hopefully you've had a go at writing down those equations. Let's go through them. Well, on this part, I've got 2. On this part, I've got 2. So I've got 2, and all together I've got 4. So 2 plus 2 is 4. And then on this part, I've got 5. On this part, I've got 5. And 5 plus 5 equals my whole, which is 10. 5 plus 5 equals 10. Lovely. So now that we've done that, I want you to pause the video again and have a think about what is the same between all of these seesaws. What do you notice is the same about all of them? Lovely. Hopefully you've got some ideas in your head. Let's see if you said any of these things. They all have the same number of children on each side. So whatever the seesaw is, there is an equal number of children on each side of the seesaw. And actually, the total number here, 2, total number 4, total number 10, the total of them is an even number of children. Maybe you didn't notice that, but hopefully now that I've pointed that out to you, hopefully you have been able to spot that. So when we do an addition and both addends are the same, we call that doubling. 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 Fantastic. So when we have 1 and 1, both of my addends are the same. So we could say double 1 is 2. What could we say for this one? We could say double 2 is 4. And what would we say about this one? Double 5 is 10. Fantastic. So let's have a look at these numbers then. I'm starting out with 1, 2, 3, 4, 5. But what we're going to do is we're going to double each of these numbers. So remember, double means having one counter is what I'm starting with. It means that the number that I'm adding, I'll just do that color-coded, sorry. So I'm starting with 1. If I'm doubling it, that means my other addend must also be 1. So that means I'm adding 1 more here. And now all together, I've got 2. Fantastic. So here I'm starting with 2. And we're going to double it. So that means that my addend here must also be the same as this one. So 2 add 2, or double 2 would give us how many altogether? That's right, would give us 4. Let's have a look at our next one then. I'm starting with 3 counters and I'm doubling it. So that means my second addend is the same. I'm going to add 3 more. So 3 add 3, or double 3 would be equal to 6. Lovely work, well done. Have a go at finishing the last 2 by yourself and then play the video when you're ready. Well done for having a go. Let's have a look at it then. So this one has 4 blue counters. I'm doubling 4. That means both of my addends must be the same. So I need to add 4 more. So 4 add 4, or double 4 would give me 8 counters altogether. And over here, I'm starting with 5 blue counters. If I double that number, that means I'm adding 5 more, because my second addend must be the same as my first addend. So double 5 would give us the whole of, oh, it's a daisy, it would be 10. Super. So my question for you now, which I'd like you to pause the video and have a think about again, is why does doubling a number always give us an even answer? So think about what even means, and why does doubling a number always give us an even answer? Super. So hopefully you've had a go at thinking about that and you've got some ideas in your head. But what we know about even is that they're numbers that always have a friend. So if we think back to our numicon pieces, we sometimes have numicon pieces that have those sticky out bits on the top. And that's a lonely bit of Numicon. It doesn't have a partner on the opposite side. And that's how we can tell our odd and our even numbers. Even numbers come in pairs. That means that they can always be grouped into twos. So the reason why, even when we have odd numbers, such as 3, for example, or 5, even though these at the moment, they're odd because you can see there that I can make a pair, but this one doesn't have a friend, so it's odd. Over here, I can make 2 pairs, but this one doesn't have a friend, so it's odd. Oh, whoopsie daisy. So even when I start with an odd number, when I double it, it becomes an even answer. And that's because each one of these counters will get a friend. So now you can see that it will always have a partner. And it's the same with our 5. So even though this is odd, when I double it, there will now be twice as many, so they will all have a friend. So we can say that doubling is the same as having 2 equal groups. Because on this side, I've got 1. On this side, I've got 1. On this side, I've got 2. On this side, I've got 2. So when my addends are the same, I've got 2 equal groups. So what that means then, if we've got 2 equal groups, what can we use to help us work this out? 2 equal groups means that we can use our 2 times table facts. Super duper. So over here, what I would say is that I've got 1 2 times, because I've got 1 and I've got it 2 times. Over here, I would say that I've got 2 times. So I could do 2 times 2. Well, over here, I've got 3, but I've got 3 2 times. So I could say 3 times 2. These are all different ways of saying double a number. So over here, we've talked about having 1 add 1 equals 2. We could say double 1 is 2. But when we double, that's the same as having 2 equal groups. So instead of saying 1 add 1, I could say 1 times 2, because I've got it 2 times. Over here, 4 blue counters, and I've got that 2 times. I've got 5 counters, and I've got it 2 times. So when we double, we could either say that it is 2 equal addends being added together, so 2 add 2, or 3 add 3, or 4 add 4, but that's just the same as saying that we've got 2 equal groups. So I could just say 4 times 2, or 3 times 2, and you would get the same answer. 2, 4, 6, 8, 10. You might notice this pattern, 2, 4, 6, 8, 10, being your 2 times tables, and that's because every time you add 1 more blue counter here, you then add 1 more red counter. So for each time, you're getting 2 new counters as you go up doubling each number. Super. So I've got some representations here, and I'd like you to pause the video and I'd like you to think about which representations show us double and which representations don't. When you've got some ideas and you've maybe had a go at working it out, play the video again. Okay, great. Hopefully you've had a go at working out which ones show us double. So here before the arrow, I'm starting with 7. And then, is this being doubled after the arrow? Well, doubling means 2 equal groups. So that must mean I've got 7 and another 7. Do I have 2 7s? No, I've got a 7 and a 5. So this is not doubling because my groups are not equal. Is this doubling? I'm starting with 3 fingers, and then I need to have 3 fingers and 3 fingers. Well, that means I've got 3 and 3. It's the same. I've got 2 equal groups of 3. So this is doubling. Is this doubling? I'm starting out with 4 dots on my dice. What happens to it? Well, I now get 2 lots of 4. Well, my groups are equal. I've got 2 of them, so that is doubling. What about this one then? I start out with 1 strawberry. Is this being doubled? Well, I've got an equal number, but how many groups should I have when I'm doubling? That's right, I should only have 2 equal groups, and over here I've got 3 strawberries, so this is not doubling. Fantastic. So now I've got some representations. I'd like you to pause the video and have a go at doubling the numbers on the screen. Remember, you can do doubling either by using your repeated addition and saying a number, add the same number, or we can just use our 2 times table facts, because doubling is the same as having 2 equal groups of a number. Great, hopefully you've had a go at doubling these numbers. If not, keep the video paused a bit longer. And if you're ready, let's go through those answers. So I'm starting with 4. Now, doubling it means that I would have another group of the same number. So I would have it 2 times now. 1, 2, 3, 4 again. So what I just did is I just did 4, add another group of 4, and now all together I've got 8. Or what we could say that I just did is I had 2 groups of 4, and that equals 8. Or I could say that I had 4 2 times, and that equals 8. Let's have a look over here then. Let's do this one. So Bobby has £5. This is Bobby's purse here. Carly has twice as much as Bobby. How much does Carly have? So what happens is Bobby has £5 and Carly has twice as much. Twice means 2 times as much. So the number that Bobby has, Carly has that 2 times. So what we need to do is we need to do 5 2 times, and we would know how much Carly has, which is, so remember for this, if you're still not confident with your times tables, we could either say we've got 5 2 times, which we do. So I've got 2 groups and I say 5, 10, or I could say that I've got 2 groups of 5. I could say that I've got 2 5 times, because multiplication is commutative, in which case I could hold up my 5 fingers and say 2, 4, 6, 8, 10, and either way I will get the same answer. But Carly has got £10 because 10 is 2 times as big as 5. Over here then, this is my bar model. So these 2 groups on the bottom are equal. That's how we know it's being doubled, because doubling is when we have 2 lots of the same number. So 6, add 6, or 6 times 2, because we've got 6 2 times, or maybe we've got 2 groups of 6. Whichever one is absolutely fine. But either way, I don't know how to count in my 6s. So what I'm going to do is I'm going to show 6 groups, and I'm going to say 2, 4, 6, 8, 10, 12. So then the top of my bar model would have my hole in it, which is 12. So we could say that double 6 is 12. And then over here is a different way of showing a part whole model. These are our cherry models. And we can say these 2 groups are equal. These 2 parts are equal. So we are doubling 7. So double 7 is the same as 7 add 7. Or having 2 equal groups of 7. So we've got 7 2 times, or 2 groups of 7. Now, I know I can't count in my 7s, so I'm going to show 7 groups and count 2, 4, 6, 8, 10, 12, 14. And then I can fill in the whole of my cherry model here with 14. Lovely. Right, we're going to move on to have a look at some strategies that we can use when we are doubling larger numbers. So everything that I've got here is made up with 10p's, 10p coins. So here I've got 10p. I'll write that here, 10p. That's what I'm starting with. Now, if I double it, what I'm doing is I'm adding another group of the same size. So I'm doing 10, add another 10p. Or what I could say is that I've got two groups of 10. So I've got 10, now I've got that 2 times. So I could say I've got 10 times 2. These are both perfectly correct ways of representing doubling. So I've got 10 plus 10, or I've got 10 2 times, or we are doubling 10. They are both showing us doubling 10. But now we've got to work out the answer. Now, luckily, I know my 10 times tables and my 2 times tables. That's straightforward enough. So 10 add 10 is 2 10s, and 2 10s are 20, or 10 times 2, 10, 20. Okay, let's clear that and have a look at the next one. This time I'm starting with 20. So I'm starting with 20 and I'm going to double 20. So how could I write doubling 20 as an addition? Excellent, well done. That means I'm adding the same addend here. So that would be 20, add 20. So we show doubling as an addition by saying I've got the same addend 2 times being added. But we could write it as a multiplication because we know that I've now got 2 equal groups of my 20. So I've got 20 2 times. So now let's work it out. So I started with 2 10s and now I've got 4 10s. So double 2 is 4. So double 20 is 40. Excellent, well done. Why don't you pause the video and have a go at doubling 3 10s and doubling 4 10s, and maybe writing both of those down as both an addition and a multiplication in both those ways of representing doubling. Well done if you've had a go at that. Let's go through some answers then. So 3 10s is the same as 30. So that's what I'm starting with. And we're going to double 30. So that means I've got 30 2 times. So we could represent that as a multiplication by saying that I've got 30 2 times, or you could even put those factors the other way around and say you've got 2 groups of 30. Either is fine. But as an addition, my addends have to be the same. That's right. So then I would say I've got 30, add 30. Let's have a look then. Well, I know that 3 10s is 30. So double 3 would be 6. So 2 lots of 3. If I've got 2 lots of 3, that would be 6. So double 30 would be 60. So I'm using my related number facts here of 3 add 3 equals 6. So 30 add 30 equals 60. Or 3 times 2 equals 6. So 30 times 2 equals 60. And then for our 40, we've got 4 10p's, which is the same as 40. And if we double it, then we would say that we've got 40 2 times. So now I've got 4 and 4 10p's. So I've got 40 and 40. And that would be the same as double 4 is 8. So double 40 is 80. Excellent, well done. Having a go at what happens then when we've got slightly larger 2-digit numbers. Well, what we can do here is we can use our partitioning knowledge. Partitioning, remember, means breaking up a number into smaller parts. So what am I starting with here? I'm starting with 1 10 and 1 1, so I'm starting with 11. Now remember, we're doubling that number. So let's, oh, there we go. Doubling it means that I've got that number 2 times. And as a multiplication, we use our 2 times tables to show that I've got 2 groups of 11. Or as an addition, we know that both addends must be the same. So 11 add 11, and now we need to work out our answer. Now this is where we need to use our partitioning knowledge to be able to help us. Now what we're going to do is we're going to partition our 10s and our 1s. So let's start with our, let's move these out of the way. Let's start with our 1s. Well, double 1 would give us how many 1s? 2. Excellent. Give us 2 1s. And now double 10 would give us how many 10s? 2 10s. So double 11 would be 22. Let's have a think back about using that for our second one then. So what am I starting with? Well, this time I'm starting with 2 10s and 2 1s. So I've got 2 10s and 2 1s, which together make the number 22. We're going to double this number 22, so that means I've got to double my 1s first of all. There we go, doubling my 1s. So now how many 1s have I got? That's right, I've got 4. Oh, whoopsie daisy, I forgot to fill these in. So remember, when we double, we're timesing by 2. That's right, to show that we've got 2 equal groups. Or my second addend is the same as my first. So 22 add 22, or 22 times 2 is showing us double 22. Now we can go and partition our number by doubling the 1s first. So now that gives us, that's right, gives us 4 1s. And then if we double our 10s, now how many 10s do we have? Well, 2 10s doubled is 4 10s. So that means it's 40. So double 22 is 44. Have a go at pausing the video and calculating the last number doubled by using your partitioning skills. Lovely. Have you written that as an addition and a multiplication question as well? If not, you need a bit more time, keep the video paused. And now we'll go through the answers. So what number am I starting with? I'm starting with 3 10s and 4 1s. So that gives me the number 34. There we go. So we're starting with 34 and we're going to double it. So in terms of an addition, that means that our second addend is the same as the first. Well done if you got that right. In terms of a multiplication, that means we've got 2 equal groups. We're doubling it, so we're going to have that 2 times. So we write times by 2. And because it's quite a large number, we're going to partition it and we're going to break it down into 10s and 1s. I'm going to start with the 1s. So let's double those 1s. 4, 2 times, 4, 2, 4, 6, 8 would be 8 1s, and we can see that there. We know 4 add 4 is 8. And then double those 10s. So 3 10s, 2 times, well, 3 add 3, 3 10s add 3 10s is 6 10s, or 3 times 2, 3 10s times 2 would be 6 10s. So that would give us 68. Well done if you got that right. Okay, now we're going to have a look at what happens when we have a number with 5 1s. So we've got the number here, 15. I've got 1 10 and a 5. These 5 represent 5 1s. Now when I double it, the two 5s come together to make a whole 10. So let's just have a look at these in terms of their equations. We've got 15 here, so starting with 15 on both of them. I'm doubling it, so that means I've got 15 2 times, or my second addend is the same as my first, so 15 add 15. Now when I've got my two 5s, that's the same as a whole 10. So 5 add 5 would make an extra 10. And then 1 10 and 1 10 would be 2 10s. So altogether, I've got 1 10, 2 10s, and 3 10s. So that would be 30. There we go. I'm going to clear that. And we're going to have a look at that next one then. And I'll cover this one up. So there we go. We've got now, how much am I starting with? 2 10s, 5 1s. I'm starting with 25. And as an addition, that's the same addend twice. And we know that when we've got the same addend twice, we can say that we've got 25 2 times that by 2. So there we go. I've got 10, 20, 30, 40, because I double my 10s from 2 10s to 4 10s. And when I doubled my 5, that gave me an extra 10. So altogether, I've got 5 10s. 5 10s is the same as 50. And I've got no ones outside of that. So 25 times 2 is 50. Super. Ooh. I'm now going to show you the next one. Pause the video, have a go at calculating it as an addition and a multiplication equation, and then we'll go through the answers in a second. Super, hopefully you've had a go at that. Let's have a look then. So I've got 1, 2, 3 10s and a 5, that's 35 this time. So I'm starting with 35, there we go. And in terms of an addition, I've got 35, add 35 again, it's the same addend twice, well done if you got that right, or I've got 35 2 times in 2 groups. So 35 times 2, they are both ways of showing us double 35. So this time, let's have a look at our 10s. So I've gone from 1, 2, 3 10s to now having 4, 5, 6 10s. But then when I doubled my 5, that gave me an extra 10. So now I've got 7 10s. I've got no ones outside of that. So 35 times by 2 is 70. Lovely. Why don't you have a go at pausing the video and doubling these for me? Lovely. Hopefully you've had a go at doubling those now. Let's go through the answers. So I've got my 10p coins again. I've got 10, 20, 30, 40, 50, 60. So double 60 would be the same as 60 add 60, or 60 times 2. So if I've got 2 groups of that, there we go. How many 10p's have I got now? I've doubled it. I've got 2 groups. That's right. I've got 12 10p's. So what I can do is I can use my knowledge of single digits to help me out here. And I can say, well, double 6 is 12. So double 60, if we think about those relationships, double 60 would be 120. And I'll pop that there. So we could have said double 6 is 12. So double 60 is 120. And we can see that by having 12 10s, and we know that 12 10s is 120. Right, let's go and have a look at this one here, then this bar model. So my bar model is showing me that one of my parts is 45. Well, I can see that this part is equal to this part, and we are learning about doubling today. So I know that this part must also be 45. So what we can say is double 45. Now just type this out. Double 45 is the same as doing either 45 add 45 or 45 2 times. So I can see that it ends in a 5 here. So I know that these two 5s are going to make a 10. And then I've got my 4 10s and my 4 10s, which is altogether 8 10s, which is 80. And then all I need to do is add those two bits together. So 80 and 10 is 90. So double 45 is 90. Right, let's go back and have a look at this then. So I've got the number 10, 20, 30, 47. I'm starting with 47. So what I'm going to do is I'm going to double 47, which is the same as saying 47 add 47, or 47 2 times. So again, we're going to have to partition it. So let's separate our 10s and our 1s. So now if I double my 1s, 7 add 7, or 7 times 2, where we could do 2, 4, 6, 8, 10, 12, 14. So 7 add 7 or double 7 is 14. And I'll just keep a note of that there. And then now we've got to double our 10s. Oh. So I've got 4 10s and I'm going to double those. And now I've got 8 10s. And all I need to do is add those together. 80 add 14. Well, 8 10s add 1 10 would be 9 10s, that would be 90. And then add my 1s, 94. So double 47 would be 94. There we go. Right, last one, our cherry model then. I've got one of my parts as 72. I know that my other part must be equal to it because we are doubling. That's not equal, that's equal. So 72 doubled, we would say double 72 is the same as 72 add 72 or 72 2 times. Getting on to some really, really big numbers here. So let's have a think about how we would do it. Well, we need to partition, don't we? We need to split up our 10s and our 1s. So first of all, let's double our 1s. There we go. Well, double 2 would be 4. Excellent. 2 add 2 is 4, or 2 times 2 is 4. And then now let's double our 7 10s. So 7 add 7 is 14. So 7 10s add 7 10s is 14 10s. And we know that 14 10s is 140. So now all I need to do is add my 140 to my 4 1s. And I know that it's 144. So then double 72 is the same as 144. There you go. Okay, the last thing we're going to go through before I introduce your independent work is a word problem. So Aya has £8 in her purse. Adam has twice as much money as Aya. How much money does Adam have? So whose amount do we know? Adam's or Aya's? Excellent. We know that Aya has £8 in her purse. So in Aya's purse, I'm going to write that she has got £8. There you go. Aya's got £8 in her purse. Now, what I do know is that Adam has twice as much money as Aya. So whatever Aya's got, Adam's got that twice. That means 2 times more. So what that means is we are going to say that Adam has got 2 times the amount as Aya. So that means we need to do 8 times 2. Now I don't know how to count in my 8s just yet, so I'm going to do 8 times 2 and count in my 2s. 2, 4, 6, 8, 10, 12, 14, 16. So that means that Adam has got £16. Super. Why don't you have a go at doing this one? I'm pausing the video and then we'll go through it together. I'll read it aloud first though. Sammy bakes double the amount of cakes that Zara bakes. Zara bakes 11 cakes. How many cakes does Sammy bake? Pause the video, have a go. Lovely, well done for having a go at that. So let's read our questions. Sammy bakes double the amount of cakes that Zara bakes. Zara bakes 11. So whose amount do we know? Whose amount do we have a number for? Well, 11. Who bakes 11 cakes? Zara bakes 11 cakes. So in Zara's box, I'm going to write that she bakes 11 cakes. Now, what do we know about Sammy? We know that Sammy bakes double the amount of cakes that Zara bakes. So whatever Zara bakes, Sammy bakes double that. So that either means he bakes 11, add another 11, or what we can do is just say that he bakes twice as many. Double that just means timesing that by 2. Now I can't count in my 11s yet, so I'm going to count in my 2s 11 times for the answer. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. There we go. So how many cakes does Sammy bake? Sammy bakes 22 cakes. Whew, that was really tough, but well done, everybody. It is now time for you to have a go by yourself. So the circle sheet is an opportunity for you to double your numbers. So double these. So I've got 3 books here. If I'm doubling it, that means I've also got 3 books here. So now double 3 is the same as, what do I have altogether? 6. Well done. So double 3 is 6. So fill that in for your circle sheet. You can either pause the video here or you can download these worksheets from the home learning section of the Byron School website. This is your circle sheet continued. You have got to finish the pictures. So this is for draw double 4. Well, double 4 would be 4 again. There we go. Whoops a daisy. That's better. So double 4, I've drawn it. So now I know that double 4 is 2, 4, 6, 8. Excellent. And then for this one, you've got your whole and you now need to work out what it is double of. So 6 is double. What have you got 2 times? Write it in the box. Once again, pause the video here or download the sheets from the website. Semicircle sheet, then we've now got bar models and cherry models, our range of part wholes. So here I can see I've got my 2 equal groups. 2 add 2, double 2 is the same as, double 6 is the same as. Things like this where your other parts aren't filled on, well, we know that we're doing the same add end twice, or we've got this number 2 times. So think about making sure that your groups are equal. Triangle is a reasoning challenge for you. You need to tick all the examples that represent double 4. So think about those pictorial representations. Think about representing it as an addition and a multiplication and all the ways that we can show that something is being doubled. There is more than one. Please be aware. Square sheet then. Square sheet is where it gets a little bit more challenging because we're looking at doubling those larger numbers, those multiples of 10, those numbers that have 5 ones, and those 2-digit numbers where we need to partition those 10s and 1s. And you've got those to do in your pictorial representations as well as in your part whole models as well. Remember to use your partitioning strategies and your related number facts for those. And then your pentagon sheet is an opportunity for you to do some word problems. So the way that I've done this is that I've written down the word problem for you here, and to help you really understand the word problem, I've written a space for you to write the calculation that the word problem is asking you to do, and then a space for your answer. So let's do the first one together for this one, if you're going to do the pentagon sheet. Remember, you don't have to do all the sheets. I have seen some people do all the sheets, and that's amazing. I love seeing that. And some of you are very, very capable of doing all the sheets, but remember to do the sheets that are most appropriately challenging for you. So let's do the first one together for those of you that are going to have a go at this pentagon sheet. Han has 6 sweets. Dom has double the amount of sweets as Han. How many sweets does Dom have? Well, we know that Han has got 6 sweets and Dom has double. Double means the same amount again. So we could say 6 add 6, or we could say 6 times 2, because we're doubling. Doubling just means we're using our 2 times tables, and then we write our answer. So Han has 6, Dom has twice the amount of sweets. How many does Dom have? So 6 times 2 equals, well, I can't count in my 6s, so I'm going to count in my 2s. 6 times 2, 4, 6, 8, 10, 12 is my answer. So that's how I'd like you to fill in that sheet. Really tricky stuff, guys. Well done. You're all doing an amazing job. Keep sending in your super work. We love seeing it, and we will see you soon. Bye, everyone.